Okay, so last thing about organic is the reactions that can happen between organic molecules or two organic molecules. So the first one is burning. You can burn organic molecules. So all you do, take any hydrocarbon, anything made of C's and H's, a whole bunch of C's, a short thing. You mix it with some oxygen. Remember, you always have to like fan a fire to keep it going. And it burns, and the product, what comes out of the tailpipe of your car, is CO2, right? The greenhouse gas, and water. That's why it kind of looks like fog in the morning coming out of a tailpipe. So the one that we use, the hydrocarbon that we burn in our cars, is octane. So it's 8 C's with H's all around it, single bonded, octane. The one that you use in a little Zippo lighter is butane. So that's 4 carbons bonded. And the one in your grill, your gas grill, is propane. So 3 C's. So it's just any molecule of C's and H's, burn it with some oxygen, you get CO2 and water. Okay, substitution, organic substitution is kind of what it sounds like. You take just any alkane, okay, and you have something you want to stick on there. So you're going to substitute it in. You're like, we didn't really want these H's. They're just here for filler. These 2 F's are going right there, okay, right where those H's were. So you substitute in the F's. So what you get is the original molecule with the H's that were there. But then instead of these H's that were here, you're just going to stick on those 2 F's. Okay. And that is substitution. You literally substitute something in. Usually happens with like halogens because they only want 1 bond, and knocking off an H is where you can get 1 bond. Okay, addition looks really similar. It's not an alkane, it's an alkene. It's got a double bond in there. Remember, ene means double bond. Still adding 2 fluorines, F2. But this time, instead of substituting, like knocking off 2 H's to substitute in, it just says addition. It doesn't say substitute in. So I'm not going to get rid of these 2 H's. Do you see anywhere in this molecule that's like, looks like a free space to put some 2 F's that I want to put on there? Yeah, there's nothing right here, right? So that is where I'm going to stick the fluorines. But that would give these C's too many bonds. They'd have 1, 2, 3, 4, 5. So how can I reduce that? I crack open this double bond and make it just a single, so I have room. All right, so let me draw that. So I'd say, okay, let me take this original molecule. Okay, and it's not called substitution, so I'm not going to substitute. I'm not getting rid of any H's this time. I'm just adding because it's addition. So I'm just going to say, all right, this, what was a double bond? Let's just make it a single bond. So now I have room to put in these F's so that now I don't have like too many bonds on the C. So substitution was like knocking off 2 H's to substitute in 2 F's. Addition was when you have a double bond, just make it single, and now that opens up these 2 spots to add 2 F's without having to substitute out any H's. All right, next one is esterification. What do you think esterification is making? An ester, okay? I love organic. Everything sounds like what it is. Esterification is making an ester. How do you make an ester? I have a good memory trick. So Esther, right, sounds like an old lady's name, sweet old lady. So what does that sweet old lady Esther like to have? She likes to have alcohol plus acid. Naughty Esther. Okay, so the way to make an ester is actually alcohol plus acid makes ester, plus she's a little dehydrated. She has to have some water. All right, so how do you make ester? How do you make things that smell nice? You take some sort of alcohol and some sort of acid, and you get some sort of ester and some water. So if you ever saw that, if they showed you a reaction and you went, oh, that's an alcohol with an OH, that's an acid with that double OH, they're getting together, that must be making ester. That must be esterification. All right, so speaking of organic having great names that sound like what they are, saponification, what's that the making of? Soap? Yes, it is. Saponification is the making of soap. Almost says soap, but not quite. How do you make soap? You just take like any long chain of C's and H's, any alkane, and you stick a base on it, because remember you have to have that like charged end, so one end can stick to the stain and one end's. So you end up with like a polar end that has like a plus and minus. That's the base end. And then you have this like, that's the polar end, polar. And then you have this non-polar end that's just like CH, super like even and non-polar. And now you have this like charged polar end that can stick to water. And then you have this very non-polar end that can stick to oil, which is what most stains are made out of. And remember, soap is awesome because it can stick to your stain, but it can also stick to water so that water can wash it away. So how do you make soap? You just take a long chain, like any fat, like people used to make it from whale blubber. In the movie Fight Club, they make it out of like human fat from liposuction. That's gross. We use it from we use plant oil, like aloe vera or something. So just take any alkane, any long chain of C's, stick a base on. So saponification is just an alkane plus a base makes soap plus this thing called glycerol. So if you were asked to identify what kind of reaction is this, so you'd go, okay, that's an alkane and that's a base. That must be making soap. That must be saponification. Okay, fermentation is making of what? Ferment. What is that? Alcohol, right? The product of fermentation is alcohol. And can you believe the creating of alcohol, the discovery of the reaction fermentation was discovered by humans long before saponification? That means that people invented alcohol before they invented soap. So they were drinking and getting drunk before they were even cleaning their bodies. That's where our priorities are at as humans. Okay. So we invented alcohol before soap using fermentation. So you just need any sort of sugar plus an enzyme. So that's why different alcohols, what's the sugar in wine? Grapes. What's the sugar in beer? Comes from wheat. What's the sugar in tequila? I think it's like agave or something. What's the sugar in sake? That's Asian alcohol. I think it's rice. Okay. So you just need some sort of carb, some sort of sugar, and an enzyme, and you kind of let them sit, and they ferment, and it makes alcohol. And then what's that bubbly stuff that's in some alcohol is CO2. So I just remember it makes alcohol plus the bubbles. So if you've ever let some apple juice go bad, it will start to ferment. It'll have this maybe alcohol-y smell. Maybe your kid left a sippy cup of apple juice under the couch, starts to ferment. It will start to form alcohol, but don't drink it because it's not done in a clean way. So it's also gonna have mold and bacteria. It'd be really disgusting. So do your own fermentation. Some people during Prohibition, when alcohol was illegal, they did their own home fermentation, and sometimes they would do it wrong, and they would create either formaldehyde, and they were which you put in dead bodies. So they were literally preserving, embalming themselves. And it was ruining their nerve endings, and they would get these shakes, and they would just slowly damage their nerve system until they died. So yeah, don't do fermentation incorrectly because you won't get an alcohol. You'll get an aldehyde or something else that's bad for you. Or you'll get a different kind of alcohol that's not good for drinking. All right, polymerization is the making of what? It's the making of a polymer. Again, I love organic. Everything sounds like what it is, unlike redox where everything's flipped. So polymerization is the making of a polymer. You've probably heard of this rope is made from a plastic vinyl polymer, or the siding on my house is plasticky. It's made from some combination of polymers. So any plasticky, rubbery stuff that we use is usually a polymer, and that's maybe where you've heard the word. Or certain paints have this rubberiness to them. They'll say there's a polymer in them or something. So anyways, a polymer, again, organic, love it. Poly, it just means a long chain of the same thing. So really any organic compound is just C, maybe with an OH stuck on the end or something. So all organic compounds, molecules are polymers. They're just long chains. So how do you make a polymer? You just hook a bunch of the same thing together. And just making that long chain, that polymer, is called polymerization because you're making a polymer. So all a polymerization is just any monomer, any little unit like A, or C, hook them together, and now you've made a polymer. So natural polymers in our world, protein is a polymer. Remember, you made them in your biology rooms, and it was amino acid, and it was all these different colors, and your teacher hung them up. Protein is technically a polymer because it's just a long chain of amino acids. Carbohydrates are also a polymer. That one was, I think it was like pink, and it was like glucose, 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 just over and over again. Carbohydrates are a polymer. Cellulose, what's in your paper, because it's in trees and it's in all the cells of all plants. Cellulose is a polymer. It's just a long chain that makes up, picture like the bark of a tree just being one long chain of cellulose polymer. We also make our own synthetic polymers, and that's where you usually hear the word. You don't usually hear it for like natural polymers. So synthetic polymers are usually the ones you hear about, like all those rubbers and plastics and man-made stuff are usually polymers. So polyester, think about it, polyester, what's it a long chain of? Esters, right? So polyester is just a long chain of esters that we figured out how to do ourselves. Polystyrene is styrofoam, and it's just a long chain of, I'm not sure what styrene is. Nylon is a long chain. Polyethylene is a long chain too. So anything that's a long chain, whether it's natural or synthetic, is a polymer, and it's made by polymerization. Okay, that's it. You did it. You're done. Have a wonderful summer. I miss you guys so much. I hope you come back and visit next year.